All right, so we're going to continue looking at different ways that we can represent data. Another way we can do that is by looking at a histogram or building a histogram, and that's what we're going to do here. So this is based upon another video where I took some data based upon the number or the amount of money spent per person in different countries. And what I did was I took the frequency of each category and I just wrote down the frequency of each category. Namely, for instance, if a particular country spent $215 on medical needs per person, that would put them in the zero category because everything after that was in the thousands. We also talked about the fact that in the previous video that the nines here, which is 9,000 and some change there, was how much the United States spent per person on medical care. So these are the different values. So the ones here is the thousands, if you will. The twos would be the 2,000s, 3,000, 4,000, 5,000, 6,000, 7, 8, 9 thousands as we go through that list. This, of course, is from a few years ago. So with inflation and all other costs associated, I bet this is probably significantly higher now than it was just a few years ago. But these are the numbers we're working with right now. Now, if we're going to create a stem and leaf plot, we essentially create something that looks kind of like a histogram, especially if we line it up properly. And that's one of the important things about the stem and leaf plot is that you really just want to line it up. And I have some videos where we did that in Excel. And Excel automatically spaces that out for you, so it's very easy to look at. And if you do it by hand, you need to put some energy into making sure that you keep all the columns lined up as well. So we'd create the rows like we have here, but instead of saying there's 8 of them, we'd list all 8 of those values. In this particular case for the zeros, it was 2, 2, 3, 6, 7, 7, 8, and 9. And you'd list all of those separately, and you'd keep them, the columns separated. Now what we're going to do here, though, is we're actually going to graph these to create my two sides of my graph here, just like this. And you can use graph paper. You have a ruler, you can create yourself something as close to a nice straight set of perpendicular lines as you can make. And on the bottom here is going to be these different categories, if you will. And up the side is going to be the frequency. So along the sides is dollars, international dollars is the way that the graph was broken down. Per capita for healthcare, and I'm just going to do a bunch of abbreviations just for speed here. And then up the side here, I'm going to turn that just a little bit. This is the frequency of those, okay? And you kind of want to mark this out as best you could, and keeping it even. Now, an easy way to do this is using a ruler. In this particular instance, I'm actually going to just use centimeters to mark these spots with. There's 1, 2, 3, 4. And I'm going through this process just so you can see me do the entire thing. Right? So that goes through 1, 2, 3, that's a funky 3, 4, 5, 6, 7, 8, and 9. Now, if we look at our frequencies here, our frequencies range from 0 up to 9, so we need to make sure that we have those listed there as well. And I'm just going to set my ruler. There's different ways you can do this, of course. But I'm going to set my ruler so that 9 is right here, so that way when I walk all the way up to the top there, I should have 9 on that. All right, so I can even do it that way too, starting off at 10. Doesn't really matter. I just need to mark off enough to get all the way to the top. Okay, and then 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, a couple of things that we want to point out here is that the vertical axis here, our dependent axis as it would normally be, is actually labeled fairly accurately. It's supposed to be frequency. This one down here isn't, though. Our dollars down here, this is not measured, done correctly, because I'm measuring here in 1, 2, 3, 4, 5, 6, 7, 8, 9. But these values right here for these different quantities are thousands. So what I'd want to do is make a note that, just saying I'm measuring this in thousands here. Okay, so this is 0 right here would take us all the way up to 8. So there's that spot right there for that. And then to keep the lines as neat as possible, Here's my first bar. And you could have absolutely have created more space and just put 0 inside that realm as well. It doesn't really matter. Next one here is 1, and I have 9 on that one, so that would put me right here. And then of course I just draw that out all the way down like that and shade that in as best I could. You can absolutely make these wider so that they're touching each other, because in actuality, what we're in this particular instance, these values are actually very much discrete values. They're very countable, and what we mean by them being discrete is that there is a separation between them, so the chart itself doesn't really matter. Essentially, what we are building here is a bar graph, but we're building a bar graph based upon these frequencies here. And I'm just going to go ahead and build the rest of the bar graph, and then pop back in here in just a second. All right, so here we're back, and we've got the histogram built. Now, the advantage of what we're looking at here is over the similarity plot is that it's oriented differently, and we can actually compare the bars instead of comparing the numbers. It gives us a little bit different perspective on it. We can, one of the advantages of the doing a box and leaf plot, or probably not a box and leaf plot, but a stem and leaf plot, is that we could physically count out these spots on the graph and find the middle spot and see what's above and see what's below, literally. Here we're this a little differently, but we can definitely see on this one that when we look at this, it looks like it's a little, there is a dip here, of course, but for the most part, we have a lot of occurrences here at the beginning. So there's a lot of places that spend very little money in comparison to in comparison to some other countries like the United States and a few others that are up here, the United States being the outlier there, of course. But there's a lot of interesting behaviors that we can identify by looking at this versus the other one. And then there's other things we can do. One of the things we can look at is the data normal, which we'll talk more about that later in more detail. But the idea of it being normal means that it follows a nice little smooth curve where there is a single peak in the data. This doesn't have that. This actually has 2 peaks, one there and one there. So this isn't normal. Is it uniform, which is another common one that we'll look at. Uniform means that you more or less have the same occurrence occurring repeatedly, which we don't have that either. So this is neither normal nor uniform. And there's a lot that we can draw out of that. Another piece is if we start talking about, say, an expectation of how often something occurs, we can start answering those questions with this as well. And when we start talking about the likelihood of events occurring, sometimes we can start using these histograms to identify the likelihood of particular events occurring, especially based upon what a particular event is like, is the possibility of an outcome occurring. Okay, so what I mean by that is when we look at these two pieces, where do we expect most of the industrialized world to fall in terms of how much money they spend on healthcare, which looks like there's a huge chunk of it right there. You're talking about 17 of the 30-something, I think it was 34 countries that were surveyed for this. So you're talking roughly half of the industrialized countries are spending less than $2,000 on healthcare per person. Now, and that is adjusted from country to country, so that's not necessarily talking about pesos versus the dollar. But what does that mean in terms of other things that we can talk about? If we were to pick a person at random, for instance, what would we expect a person just picked at random on the planet to spend on healthcare? Would we expect them to spend less than $2,000? Would we expect them to pay $9,000 per year on healthcare? What does that look like? What is this 4,001 right here? These countries that are in that realm, which amounts to 7 countries. What does their healthcare look like in comparison to the bottom or the top? One thing that is interesting when you start talking about healthcare expense is that in some places like the United Kingdom, and the United Kingdom is, let's see, where were they? They were in the 3,000 mark, so they were actually here, right? So they're not necessarily in the bottom half, but they're really inexpensive by comparison, because they are still talking about it being roughly a third of the cost of the United States healthcare. one interesting aspect of this is that people with diabetes in the United Kingdom actually receive better care in the United Kingdom than people with diabetes in the United States. They actually have a longer lifespan, and they have fewer complications. So their overall health is better in the United Kingdom, and they're spending far less per person in the United Kingdom. And one of the things that's interesting is in the United Kingdom, insulin and testing materials for people with diabetes is completely covered under healthcare. In the United States, that's not always the case. So what they found, there's an interesting aspect, is when you provide all of that preventative care, they don't need nearly as much other care down the road. You don't have the other complications that go along with that. Now, there may be other factors involved in that, but what they found is that simply by spending a little bit more on the front end, they're spending a lot less on the back end. And that's one of the things about the United States healthcare is there tends to be a little bit more money spent on the back end. And also the United States does a lot more testing in healthcare than other countries do. And that may be one of the reasons why you have this right here, this group right here in the 4,000s. I hope these videos are helpful. Please let me know if there are pieces missing and you need additional videos about any particular topic. Thank you.